Alrighty, here we go. So yeah, today we're looking at law of sines, law of cosines. Okay, law of sines should be review for everyone in here, right? If you were in a geometry class.
I think we remember when we took geometry. That was 2 years ago.
I mean, I like to think that all of my geometry students remember everything that I taught them. Right, Chrissy, Maddie G, anybody else in here? Samantha? I said, I like to think that everyone in my geometry classes remembers everything that I taught them. Perfect. All right, good. Excellent, excellent. All right, so I'm going to draw a triangle here. So the law of sines and the law of cosines, all right, are two kind of like relationships that allow us to utilize trig functions, specifically sine and cosine, thus the name law of sine, law of cosine, allows us to use trig functions in triangles that, well, let me pause right there. So in order to use sine, cosine, and tangent, what kind of triangles must we be working with? Right triangles, right? Because sine, cosine, tangent, cosecant, secant, cotangent specifically relate angles in a right triangle, the acute angles in a right triangle with a ratio of sides, okay? That's kind of limited though, right? Because in a non-right triangle such as this, right, I don't have any angles marked as right angles there, okay? B kind of looks right, but it's not labeled that way. We're not told that it is, so we shouldn't assume it is, right? We can't use sine, cosine, tangent, right? It's not a relationship that's allowed. However, we can use something called the law of sines, okay? And so what that is that the sine of angle A over side lowercase a. And we assume that angle A is opposite its lowercase side there, lowercase a side. Okay, so angle A, capital angle A, and then lowercase side a there. Okay, and then B is opposite side B, and then capital C is opposite side lowercase c. So the ratio of sine of angle A to its opposite side is the same ratio as the sine of angle B to its opposite side is the same ratio as sine of angle C to its opposite side. Samantha, are you remembering this at all now? No. Perfect. Excellent. Excellent. All right. Well, I guess that happens, right? I won't ask Maddie, G, and Chrissy that way. I'll pretend that someone still remembers, but that's okay. Anyway, so there's the ratio there. There's the ratio right there. Okay. Of course, you could write it in the exact reciprocal if you wanted to, where you have side A over sine A, side B over sine B, side C over cosine C. Thanks for the delivery. Yes, I'll check it off. I'll take it. Thank you. Because I paid $15 to Mr. Welch to be part of the muffin club. And I get 5 deliveries of a tea or coffee of my choice, along with a muffin of my choice. And he puts out like a little menu on like Tuesdays. And see, here's my little ticket right there. I have to scratch off 1 beverage, 1 muffin. And there it is. I get 1 more. So I got a cranberry orange muffin today. Yeah, possibly. But I figured I would, try this out, see how it goes. Yeah, so $3 for a muffin and a tea or coffee. I'm like, anyway. So we'll keep going here. I'm still appreciative of it, though. I still like getting those deliveries. They're delicious. All right. So anyway, how are we going to use this? Well, we're going to use it to find missing parts of non-right triangles. So let's solve for the missing pieces of the triangle below. Oops, off the screen. Let me see. Let me zoom out 1. Click there. Okay. And you will want to have your graphing calculators handy here too, so heads up on that. So remember this? Okay, cool. Sort of. It's like kind of like just distant memories. Well, good. Good. I'll tell Mr. Weiss that one of his former students kind of remembers the law of sines, law of cosines. Or law of sines here. Okay. So we're asked to solve for the missing pieces, or sometimes the directions are simply solve the triangle, and to solve a triangle means to just find all its missing parts. All right. So, what can we find here?
The last angle.
Ah, okay. Yeah, very good. Right. Without using any sort of new stuff, right? We can find that last angle of the triangle. It's what?
50 degrees.
Close. It's 40 degrees.
40.
And how do you get that? What are we supposed to do,
Already
Ro?
because you just add the other two.
And
then take 180. I mean, yeah, 180 and subtract it.
yeah, exactly right. So 180, right? All the angles in a all the angles in a triangle, okay? And Euclidean geometry, right? Add up to 180 degrees. And so that's where it comes from. All right, we'll be here. All righty. So now we've exhausted all of our possible, all of our information that we could find without using law of sines. Now we're going to use law of sines, okay? And so when it comes to using the law of sines, okay, I would suggest that you start with a known angle / opposite. Gotta get off the screen again. Opposite side pair. Okay, I went off the screen. Okay, so when you're solving using law of sines, you always want to start with a known angle / opposite side pair. So in this case, what is the pair of angle and opposite sides that we know? The 43 degrees is angle A, right? It's A. 43 degrees for angle A, 22 for side A. And so we'll start with that. And it doesn't matter whether you write 22 over sine of 43 or sine of 43 over 22. You can set it up either way. I'm going to do sine of 43 over 22. Just because. Okay. Now, at this point, we need to solve for another side. Okay. So it doesn't really matter which one you pick. Let's do C. Let's solve for side C here. So we'll say sine. What's that?
97.
Yep. Angle C is sine of 97 degrees over, and we'll put a little c there to represent the length of side C.
Wouldn't you just cross multiply?
And exactly right. It's a ratio, it's a proportion, so we're just going to cross multiply to solve this. Yep, exactly right. So we'll get C times the sine of 43 degrees equals 22 sine of 97. And you can skip as many of these cross multiplying steps as you like. If you can instantly get C by itself there, that's fantastic. But if you can't, then feel free to take your time writing it out and dividing both sides by sine of 43 degrees so you get this. Okay? So this is, of course, our precise answer. Okay, this is, of course, our precise answer. So go ahead, let's type this into our calculators here, see what we get. Type it into our calculators. What's that? What do you think it should be in? Adrian, question? Good question. So look at the units that are in the problem. What do we think it should be in, right? Yeah, so did anyone get an answer like this? Negative 10?
Yeah.
First.
Yeah, so does that actually make sense? No, but I typed everything incorrectly. What did I do wrong? I'm in the wrong mode, right? I'm in the wrong mode. Okay, so mode button, move it to degrees, make sure you hit enter, then do it again, and voila, there's a more appropriate measure. If you'd like, sure. I'm going to use 3 decimal places here, though, when I do it. So I'm going to say this is approximately 32.018, I'll say. Okay? Correct. Now, I would recommend, though, Ro, so listen up here, folks. I recommend, so Ro's right? Now that we know that C is 32.018, you can use either, sine of A over side A or sine of C over side C. My recommendation, though, is use this again, and the reason why is because if you made an error here, that error is going to carry through when you go and find B, whereas here we know these numbers are correct, so I would say reuse these to then find side B. And now it causes some error as well, although that shouldn't cause significant enough error where it would be like way off kind of thing. But it would be a little off, exactly right. And that's, again, for those of you planning on going on to calculus next year, okay, or maybe even statistics, I'm not so sure if they're concerned about that or not. Again, notice we didn't do any intermediate rounding here. These are all exact values of C, and at the very end, once we had the exact precise value of C, we then typed into our calculator to get this estimated answer for C. So in other words, you should not do 22 times sine 97 here, get the decimal, and then divide by sine of 43. You should wait until the end to get the exact answer set up in the expression there, and then do the math to get the actual the decimal answer. Okay? Again, that's for those of you that really are planning on going to calculus. You want to get into good habits for calculus because that's what is required there. Okay, so let's do another setup here. We'll do, again, the sine of 43 over 22. And we'll say that's equal to sine of 40 over, well, we'll say that's b, right, little b. Okay, and so dot, 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 cross multiply and solve. You get b is 22 sine 40 over sine 43. Okay, so we'll type that into our calculators. Make sure you close the parenthesis on that sign in the numerator, by the way, right? Don't forget to close that parenthesis. It's not necessary to put parentheses around the numerator if you don't want to, but it's not a bad idea too. So in other words, put parentheses around 22, like that, sine 40, and then sine 43 in the denominator. Okay, so about 20.735. Okay, and so there's our other missing side there. All right, questions on any of that? No questions so far? Okay. Let's keep going here then. Let's try a different one here. Actually, you know what? I'm going to have you guys try this one. We'll just have you try this one. Okay. Lowercase letters are just length, yes.
That way, we're not doing radians.
And we are not doing radians, we're doing degrees, correct.
Which is why we have the mode.
Which is why we have the mode to switch back and forth. Okay, so again, solve that triangle. Okay, solve that triangle, please. And I will do the same. Oopsies. Silence. OC. Let's see here. I got the 13.552. Oh, that's a 50.
Did you get something? Yeah, I just.
So I kind of like a 10 with the short pattern. That's fine.
Goose goose.
Yes.
Is it okay if I did this?
Oh.
I just set them all equal to each other.
That's bad.
I mean, if you're confident that you can like not make any mistakes in the intermediate steps, then yeah, that's fine.
Alright.
Yeah.
I remember this too.
You do?
This is like my favorite thing.
Yeah. Good. 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 Nightmare.
My teacher was nine. Was not.
Just opposite side. Who did you have? Your Thompson?
No, I'm Mr. Kennedy from Centennial High.
Different teacher, right? Different instruments.
Those big yaks.
Yeah. Lots of proofs.
Yeah.
Oh, sorry.
Now we're
Centennial's in Berlin. Berlin.
on the first week we had a big conference. Yeah.
Oh yeah, I think you told me about that.
I did. was great.
That's crazy.
Wait, are we gonna be doing proofs?
Not in this class, no. But we're gonna do something kind of like proofs, trig verification.
We're not doing proofs, are we?
Not really, but kind of, but not really.
I remember hating proofs.
What does that mean?
I think you might hate them as much as you do proofs for a similar reason. So yes, Samantha.
I don't know, did we do proofs in Mr. Walker's class?
You guys did proofs?
I don't know.
I don't remember what class it was. It could have been geometry. I remember.
I remember hating it.
I remember hating it. I vaguely remember proofs. I just remember that.
Bless you.
Size.
Okay.
But I associate them
You
with
took your
bad.
Vita poison ivy. She could vouch.
Poison ivy, as
Yeah.
in the plant.
Because I
I guess.
always never. I'm itchy, annoying, and never go away. That's how he described it. But he wrote me a call. He wrote me a call letter for recommendation. So.
Right. Well, right, because there's like the friendly annoyance, but then there's the real annoyance too.
No, and I let her read our call.
I'm sure he was friendly annoyed with you.
But you're allowed to read them.
Questions? There are our answers. Any questions on that? So far, so good? All right. We're not quite done with Law of Cosines. I have one more I wanted to take a look at, and that is this one. Let's see here. Again, solve triangle ABC. using the given measures. Okay. Measure of angle C is 108 degrees. Lowercase c is 56. Lowercase b is 27. So go ahead and draw a sketch of this triangle. I want to make sure we can, of course, label the appropriate pieces and things too. Okay? So sketch what this triangle is going to look like. It doesn't have to be drawn to scale. Just make sure everything is in its proper place. Answers for the last one. 1 second. You should have gotten side A is, side B, 13.552, side C, 15.297, angle A, 120 degrees. No? Okay, your picture should look something like that. Yes? Maybe not exactly the same. I didn't draw it to scale, obviously, because that's very acute what I drew, and that is not acute for the actual measure. But that's okay. It doesn't have to be, exact. All right. So, our setup here. What side what angle / opposite side pair do we know? C, right? So we're going to start with C. So we'll start with the sine of 108 over 56. And I'll set that equal to, and then what piece of information do we have to kind of solve for next? We got to find angle B, right? That's the only thing we can do here. We have no way of figuring out what this angle A is. Sorry, what this side A is just yet. Okay? And so therefore we can't figure out angle A either. The only piece of information we have is little b, and that'll help us find angle b. Okay? Can I use Pythagorean theorem here to get this third missing side? Oh, it's not a right triangle. So can we use Pythagorean theorem? It's not a right triangle? Oh, we don't know if it's a right triangle. And in fact, we know it's not a right triangle because we've got an obtuse angle here. So no Pythagorean theorem. Okay? Only if it's a right triangle. All right? But of course, if it's a right triangle, then we don't really need to use law of sines. You could use law of cosine, or sorry, you could just use sine, cosine, tangent, plainly, but we don't have a right triangle here. So right, back to what I was saying. So then sine of angle B over 27. Now this is a little bit different. We haven't yet solved for missing angles, right? Everything we've solved for thus far has been for sides or the third angle by just subtracting from 180. So nope, we're sticking in degrees because our units are in degrees here. So we'll still cross multiply and solve here. We end up with sine of b equals 27 times the sine of 108 over 56. Okay, so we solve for sine of angle b, right, but we don't have b by itself, right? We want to find actual just b by itself here, and so, right, what do we have to do to both sides of this point to get b by itself? Arc sine or sine inverse. Arc sine or sine inverse. So we get angle b is precisely the arc sine or sine inverse of this quantity 27 sine of 108 all over 56. Okay, and so we'll type this into our calculator and get a decimal approximation here. Okay, 27 sine. And make sure you close parentheses where appropriate, stuff like that. Okay. And you should get, when you type in your calculator, and I recommend you do type in your calculator, make sure that you can, do this accurately, about 27.293 degrees. So, question. how do you arc? It's second sine, sine inverse. Oh, why? Because what we had here was sine of b is equal to this. I need to know what not sine of b is. I need to know what angle b is, because I got to figure out what angle b is for the triangle there. So then we do sine inverse of both sides. Sine inverse of sine cancels out, leaving us with just b. Sine inverse of this side, well, that's why I wrote that. We have to figure what that is using our calculators. Okay. It's like using, like if you remember, Grant, back when we were talking about logarithms, and we had like logs on both sides, and to cancel it out, we would do like, if it was natural log, we would do e to the left-hand side, e to the right-hand side. Same idea here. We're using the inverse of sine to cancel it out. Using the inverse of sine to then evaluate. Okay. Now, I know that. Oh, I was gonna say. So here's a recommendation for you, because it's a lot of typing into your calculator. If you're having trouble typing this into your calculator accurately, here's one recommendation. Do this. Do what's inside the arc sine. So 27 sine 108 divided by 56. Okay, just like this. Get your decimal, and then do second sine. So you get the arc sine, and then do second answer. And so it takes your previous answer right there. You don't have to retype the whole decimal there. You can just use that, and voila.
Or you can go up.
Yes, on some calculators.
Enter.
Right, if you go some calculators, you can do that.
Yeah, because that's
Do it that way.
You just close parentheses when you're done.
Yeah, that also works.
That's just what I do.
Some of the older calculators don't have that capability, though. So that's why I was showing the answer.
What did you press to get? What did you press to get?
Second, then negative sign, yeah. Okay.
It's on the letter C.
Are we all comfortable with that then? Comfortable with doing that calculation? Because I have a little twist we got to throw in here now. Okay, a little potential for mischief.
Why?
All right. So remember back to arc sine. Okay, when we talked, remember back to inverse trig, all those painful memories that inverse trig caused about how there are sometimes multiple answers and things like that. Okay, in this case, all right, there's the potential for another answer here too, besides 27.293. Okay, and so remember that sine. So this number here, this number is positive, right? And sine is positive. I think it's positive. I think it is. Let me check here, make sure, because otherwise I will be feeling a little silly. Divided by 56. Okay, yes, it is positive, right? So 27 sine of 108 over 56 is positive there.
How would it be negative?
Okay.
How would that even work?
I guess that wouldn't make sense. You're right. In the context of a triangle, we would not be able to get a negative sign. So, but back to my point. Sine is positive in what two quadrants? First and the second. So we found the first angle here, okay? But then we also need to find the second quadrant angle here, potentially too, which would be 180 degrees minus 27.293. Okay? That's okay. You want to just get it over with that way?
Yeah.
Just go for it. You good now? That's fine. I get it. Those bags are extra crinkly. But anyway, so there you go. So 180 minus 27.293. Okay, we get 152.707 as another possible answer here. Okay. But, okay, so right. So, Ro, hang on a second, please. So, this angle, right, does this angle make sense in the context of the triangle? No, it does not. Because we already have 108 degrees plus 152, that you're going to be way bigger than 180. So, in this case, this angle does not work. However, anytime that you do, hold on, I'll be right with you, Ro. Just hang on. I got to make a point here. Your question might get answered by what I'm about to say. Anytime that you do arc sine in one of these in the context of these kind of problems here, okay, we need to consider both an angle, the angle that you get, the solution, and its supplement as possibilities, okay, because of the nature of sine. Sine is positive in both the first and second quadrant, and angles in the first and second quadrant could fit in a triangle, there, okay? This is called the ambiguous case of the law of sines, all right? And so in this case, though, since the supplement to that angle right here doesn't work, we can ignore it, and we only have one potential triangle here. If both of these angles work, then you have to solve separate triangles. You have one triangle. It's like mirror universes or something like that. You have one triangle where it has angle B is this angle. You'll have another triangle, same original measurements, but the angle B would be this angle, and then you use that to solve for the missing pieces. Okay? This is called the ambiguous case for the law of sines. Why is it ambiguous? Why do we run into the situation here, but we didn't in the earlier problems? Look at the information we're given here. Okay? In this problem here, right, we have a side, angle, side. We had an angle, angle, side that we were given here. Angle, angle, side, is that a triangle congruence? Do you remember back from geometry? Angle, angle, side? Yes, it's a triangle congruence, right? So that means this guarantees one unique triangle. Let's go down to the other one we did. This is angle, side, angle. That's also a triangle congruence, and it provides a unique triangle, a unique triangle. What's the information we're given here? Side, side, angle, or angle, side, side, right? Angle, side, side, all right? It is not a triangle congruence, so therefore we are not guaranteed one unique triangle here. Now, in this scenario, we end up with one unique triangle, but it could provide actually for two triangles, or there are also situations where no such triangle will exist. If that's the case, when you go to do your arc sign, you'll get an error. You'll get an error. Okay, sorry. Thank you, Rover. Wait. Yes.
Why don't you just minus, like, why don't you just add 108 and then the 27.293 together and then
Get your missing angle.
minus that from 180?
Well, that's what. So yes, that's what we're going to do to solve for the missing angle A. Okay. But my point is that when we went to find angle B, and we're doing this arc sine calculation, okay, there are two angles. There will be two angles on our kind of unit circle here that will have this ratio that we're trying to find. Okay? So arc sine, remember, the input is a ratio, the output is an angle. So when we did arc sine of this, we get the angle 27.293. Our calculator is going to give us one answer. But the supplement to that 27.293 is also a solution as well. In the context, this one doesn't make sense, so we throw it out. We're just going to follow along with this one. Okay?
Why don't you take minus 108 in that one, and then you can get another one that would make sense?
108 minus this one you're saying? Because
no, minus like
180 minus 108?
No, 152 minus 180.
Well, because again, this is for angle B. They're saying this is the angle measure for angle B, or it's a potential measure for angle B. If you take this and add it to 108, you're already over 180, so it's impossible for this triangle to exist with an angle B of this. What's that? 152?
You are.
What's 108? Yeah.
I thought it was just
Yes. Significantly, right? Significantly. So that's why we throw that one out. Now, that is called the ambiguous case with the law of sines. All right? It'll be very rare that you're going to run into this scenario where you're going to have more than one triangle. Okay? Most of the ones that I assign to you will end up being just one triangle where it's just that 27.293. Okay? So don't worry too much about it, but I did want to show it to you here because it is, worth knowing. Okay? So anyway, now we'll continue with this line of thinking here. We'll do 180 degrees minus 108 degrees minus the 27.293 degrees. And so we get C to be,
You mean A?
sorry, angle A, thank you. Angle A to be 44.707 degrees. Okay? And I'll put that up here. All right. And again, we have angle B is 27.293. Are we done? No. We have to find side A as well. Okay? And so in this case, we'll just use another law of sines. I'm going to stick with that sine of 108 over 56, and then sine of 44.707 over little a. Cross multiply and solve here. Okay, so there's our precise, well, I guess I shouldn't even say precise because that 44.707 is rounded. Okay, 56 sine 44.707 divided by sine 108, and we get About 41.422. Okay. Okay. Right. Again, here we are solving for a side, right? So there is one piece of information here. The only time we have to worry about that potential for two answers is when you do arc sine of this measure. Because sine is positive on the first and second quadrant, okay? And so we have to concern ourselves not only with 27.23, the initial angle we get, but also its supplement as well. Okay, again, it didn't make sense in the context, so we had to throw it out. Whew. All right. You will not need to memorize the law of sines. It will be given to you for any assessment, including your quiz. Okay? You just need to know how to use it. All righty? Questions on any of that? I just go through the whole daggone. I'm pretty sure I'm supposed to. Okay, so that's law of sines. We're going to briefly look at law of cosines here too. Okay, and introduce that. Okay, this formula you also do not need to memorize. Okay, this formula you also do not have to memorize. It will be given to you, as in, oh, okay, like what will be given to you, you're saying, I guess? Let me pull it up here. Oh, come on, man. This will be given to you right here.
Oh.
This. Okay. Yeah, we'll do that. Yep. Okay. So, law of cosines, like the law of sines, is used to solve non-right triangles. Okay, you can still use law of sines in right triangles. You can still use law of cosines in right triangles. It's just that they're also able to be used in non-right triangles. All right, so here, I think, is the formulation of the law of cosines you'll be given. Recognize that.
Oh.
Pythagorean theorem, right? But minus 2ab cosine capital C. Okay? So essentially, it's like the law of sine. Sorry, it's like Pythagorean theorem, but with like a little correction to it. Okay? With a little correction to it. Okay? You will be given this formulation, I believe. You're given one formulation. I forget which one it is. But I will give you this formulation of it. Okay? There's two other formulations, and it's just a matter of like moving around the variables here. So there's this one, where a squared is equal to b squared plus c squared minus 2bc cosine capital A. And there, well, it's because of sometimes you have to use different formulations based on what you're solving for. And then here, b squared equals...
Oh, it's a in terms of the c. And
exactly.
b in terms of
the other two. Yep. Exactly. Okay, so there are our three formulations. You'll be given one of them. I'm pretty sure it's the first one there, but it's kind of, hopefully, as Ro kind of summarized it for us there is a way to kind of derive the other two from the first one, right? It's all a matter of, so it's like c squared, that's what you're solving for, and then you'll notice it also is at the end here, the angle capital C, right? A squared has the capital A there, b squared has the capital B, okay? And then the two squared terms that you're equal to here, it's just the other two sides, minus twice the other two sides, right? So c squared is a squared plus b squared minus 2ab, and then cosine the angle C. Here for A, right, you see the b squared plus c squared minus 2bc cosine angle A, right? And then AC, and then B. Okay?
The only real thing changing is like a little bit of...
Just the positions of things, just positions.
No, the real thing changing is the angle.
Oh, okay. Okay? So, why do we need law of cosines? Why don't we just use law of sines for everything? Well, what if what if we have a triangle like this?
What a beautiful triangle.
Thanks. Okay. So, will the law of sines, will the law of sines be useful here? Why not? There's no angles, right? Because for law of sines, we need to start with an angle and opposite side pair that we know, right? Here we know all three sides, we know 0 angles. And so any way you try and set up the law of sines here, you're going to have 2 unknowns in your law of sines. So you're going to be stuck. Okay? So instead, we're going to use law of cosines here first. Okay, at least first. All right? And so I'm going to start with the longest side here. Okay, so that's going to be the 10. Okay, 10 then is going to guide which formula I use here. Okay, I'm going to use the b squared version of the formula because 10 is side b. Okay, this is little b, so I'm going to use the b squared formulation. So we're going to put the 10 equal to, and then it'll be ac squared. So it'll be 7 squared plus 4 squared minus 2 times 7 times 4 cosine of angle A. Oh, I mean B. Dur. Okay. In this scenario, you could really solve for any of the angles first, but I would recommend that you always start with the longest side. This will help us avoid any sort of like ambiguous case kind of situations and stuff like that. Okay. I would say you start with the longest side. Now, believe it or not, this is tricky for students to solve.
But it's just 100 equals 49 plus 16 minus 56 plus 90.
Yeah, right, that's right, but there's some errors here. So I'm going to run you through this real quick here. So so we get 49 plus 16 minus, I'll go ahead and multiply this out. So 14 times 4 would be 56. Yeah, cosine b. Okay. What can be combined on the right-hand side here? 49 and 16 and nothing else. Okay, so do not do 49 plus 16 and then subtract 56 here.
What if you minus the 49? And then
Like subtract 49 from both sides, subtract 16 from both sides kind of thing? Yeah, you can do that if you want to. That's fine. Okay, but long story short, for whatever reason, students like to combine the 49, the 16, and the 56 together and put that in front of their cosine.
But it's a different
And that's not right. 56 is a coefficient, right? It's not like a value there. So be careful with that. That happens more often than I think I'd like it to, right? So that's why I'm bringing it up now. Of course, now that I've shown it to you, you'll hopefully, well, you might use it, right? So anyway, subtract 65 from both sides. Okay, you get 35 equals negative 56 cosine of b. Divide both sides by negative 56. Okay, and we get negative 5/8 here equals cosine of b. Okay, and at this point, what do we have to do to both sides? To get the b by itself,
no, yeah, you can do arc
cosine inverse or arc cosine, yep. Question? 35 divided by negative 56 simplifies to negative 5/8. That's all. Yep. Thank you for asking. Oop. Negative 5/8. 128.682 degrees. All right, so a negative ratio for cosine means you're going to be either in quadrant 2 or 3. But of course, quadrant 3 wouldn't really be helpful because there's no angles in quadrant 3 that will fit in a right triangle, or fit in a triangle, right? Quadrant 3 is greater than 180 degrees, but less than 270 degrees. But we are in quadrant 2 here, right? 128 degrees. So that's our angle B. So 128.662 degrees. Okay. Does this make sense in the context of the problem? Well, B is going to be the biggest angle, and it's opposite the biggest side. So yes, that does make sense in the context in that sense, at least. Okay, question, Grant? 682 is what I've got. So I wrote 6 there. I see what you're saying. Yeah, 682. Thank you. Okay. All right, and at this point now, how can we solve for the remaining angles?
You do the sine thing.
Law of sines, right. So now use law of sines to find one more angle, and then you will finally be able to subtract from 180. So use law of sines. So I'll say sine 128.682 over 10 equals sine of angle A. You can find C or A here, your choice. I'm going to just find A. Sine of A equals 7 sine 128.682 over 10. So A is sine inverse of this mess. Okay, which is approximately 10. Okay, I get about 33.123 when I type that in my calculator. Okay. Now, like I said earlier, right, we did inverse sine here. Sine will have this ratio. It's going to be a positive number here. Sine will have this positive ratio in both quadrant 1 and in quadrant 2. So when we do sine inverse, with law of sines, we should technically check the supplement. Okay? But is it even necessary here to check a supplement at 33.123? Well, so if I do the supplement here, I get 146.877. Okay? But that angle is impossible with this other already obtuse angle here. So we can throw that one out. It's just angle A is just that one. Okay? And then we can find angle C by doing 180 minus 128.682 minus 33.123. Okay, and that's 18.195 degrees. Okay, and so there's all of our missing pieces. Okay, whoops, sorry. Okay. We're going to do a little, well, actually, sorry, I'll hold off on that. Notice, what information do we start with here? 3 sides, side, side, side. Is that a triangle congruence?
Yes.
Yes. So this guarantees one unique triangle here. Thus, when we try to figure out if there were 2 angles for sine here, that second one's going to not work. Okay? So, but make sure you do start with the longest side there to help you just with your calculations and things. Alrighty, that's where I'm going to stop there. I'll give you guys your assignment. Okay? I highly encourage you to practice this, especially for those of you that are planning on taking that the optional quiz, okay, in set next week sometime. All right. Highly encourage you to make sure you get this down. This again is very, very I don't know, comprehensible, I guess, or comprehensible. I don't know. Anyway, you can do well on this quiz with not much effort, right? You just gotta make sure you practice it and know your stuff. That's all. Okay. I give you the formula. So, page 434, 5, 9, 21, 25, 45. And these are all calculator active. Use that calculator, okay?
Is this what the quiz is on?
The quiz will be on this kind of question and then what we're going to do tomorrow.
Awesome.
Okay?
Are you giving us like the formula for all three laws?
you will get the first formulation I gave you right here. You'll get this, and then I'll also give you the law of sines, the whole thing. Okay. So you'll need to be able to derive the other two potentially, which is again just manipulating some variables around. That's all. And why do I do it that way? That's because that's how our county benchmark does it. So that's why I do it that way. Okay.
Do we have a benchmark?
Yes, at the end of class. Yes. Comprehensive cumulative benchmark. What's that? Calculator active. California. California. You guys know that song? Isn't that the theme song for Gossip Girl? No.
How would you know that?
Maybe not.
How would
No,
you
but
know
like
that?
when the show first came out, it was like really popular. No, sorry, it was the OC. That was, and you guys don't know the OC. That's too old for you. But that's like it's like Gossip Girl before Gossip Girl, I'd say.
What's Gossip Girl?
The
It's like a teenage soap opera, I would say.